In this lesson, we're going to take a look at the slopes of parallel lines. And the first thing I'd like to do is take a look at a few graphs of lines that are actually parallel. I'll put a graph in here of y equals 2x, and we'll graph that. Now, if we put in recall from before that the slope of this line is up 2 over 1, so the slope is 2 over 1. And even looking at y equals mx plus b, here you can see that m for this y equals 2x is 2, so that means our slope is 2. So we're going to put in another line here, and this time we're going to put in y equals 2x plus 3. And when we graph that, you'll note that its slope is up 2 over 1 as well, and here the m is 2. So we'll put in another one, so y equals 2x minus 3, and graph that. And you can see that all three of these lines are parallel, that they are not getting any closer, any further apart. And put in one more, y equals 2x minus 8. And when we graph that, these lines all have m of 2 or slope of 2, and these lines are all parallel. So we'll try another group, and this time we'll do y equals negative 1/2 x. And when we graph that, the line goes down to the right because the slope is negative, and the slope is negative 1/2, so we go down 1 over 2. And so if we put in another line with slope or m of negative 1/2, we'll put in negative 1/2 x plus 3. And you'll note that these lines are not getting any further apart or any closer together. So put in another one, negative 1/2 x minus 3. We graph that, another parallel line. And if we do negative 1/2 x minus 8 and graph that, once again we end up with 4 parallel lines. Now, two lines that are parallel means that they never get closer and they never get further apart from one another, so that means that they always are the same distance apart. And what you should have gotten out of that graphing demonstration is that if lines are parallel, then their slopes are going to be equal. And if two lines have equal slopes, then they are automatically parallel. So if we consider the equations we were graphing, you'll notice that all of these equations, all these functions have m equal to 2. So that means that the slope of all these lines is 2. So then these four equations, these four functions represent 4 parallel lines. And if you think about it, the rise in every case is going to be 2, and the run in every case is going to be 1, so that these lines are going to have the same steepness, and if they're rising by the same amount, or the same steepness, they'll never touch. So if we consider the other examples, when we had slope of negative 1/2, and here in every case m is negative 1/2, then that means all these lines have slope negative 1/2, and they are all parallel. And in every case they're going to have a rise of negative 1, so they're going to go down 1, and the run is going to be 2. So these lines all go down to the right at the same steepness. So that means that they also will never touch. So now if we consider a question where we've got to write the equation of a line that is parallel to 3x plus y minus 4 equals 0 and passes through the point 2, negative 5. Now, the main piece of information you got to focus in on here is parallel. And once you see in a question that a line is parallel, automatically we know we have the same slope. So the first thing you have to do is figure out what that slope is. So we got to determine the slope of the line that we're given, so the 3x plus y minus 4 equals 0. And the way we do that is by isolating y In other words, get it into y equals mx plus b form. So first thing we're going to do is subtract 3x from both sides. So this is just our equation with subtracting 3x from both sides. And that simplifies to be y minus 4 equals negative 3x. Now we have to get rid of the minus 4, so we add 4 to both sides. And that means that our equation in y equals mx plus b form is y equals negative 3x plus 4. Now, what we can do is now, since it's in y equals mx plus b form, is identify that the slope of this line is negative 3. And what we can do now is write down what we're given. So going back to the question, we know here from before that the slope m is negative 3. We're given a point to negative 5. So that means our y is negative 5 and our x is 2. So we can now just sub those into the equation, and what we require is the b. So the formula we're going to use, again, is y equals mx plus b. So we're going to sub the values from here into y equals mx plus b and solve for b. So subbing in, y gets replaced with negative 5, m is replaced with negative 3 from above, and x is replaced by 2. So now we solve for b, and multiplying negative 3 and 2 comes out to be negative 6, and add 6 to both sides to isolate b, and you get an answer of b equals 1, because negative 5 plus 6 is 1. So we substitute these values in, of m and b into y equals mx plus b, and we get y equals negative 3x plus 1. So therefore the equation of the line parallel to 3x plus y minus 4 equals 0 and passes through the point, point 2, negative 5, is y equals negative 3x, which is our m, negative 3 is our m, plus 1, which is our b.